So this is not the kind of talk that I do normally, because the one who knows me knows that I'm very passionate about Postgres. Once I put a message on Twitter saying, "How dare you criticize Postgres?" And Andreas Schenbaum answered, "I don't know who you are, but run fast." So that's not the kind of things I do, but I have to be honest, and there are some pain points in Postgres, but we will see also there is some bad faith from some users, so we'll debunk that. First of all, about my slides, before I was doing regular slides with bullet points, and I found out that people were reading my slides instead of listening to me. I'm a mom. That's very infuriating to be ignored. I already have children to do that for me, so I don't want colleagues and friends to do the same. So I removed all words from my slides. And then I had the feedback that sometimes it's not easy to follow a talk when there's no word. And for whatever reason, you might have hearing disabilities, you might have ADHD or whatever, or you might be distracting today because you're having a bad day or whatever. So what I do is I share here the slides with bullet points. It's not the slides that I will present, but it's the same one, except that there are bullet points on top of it. Also, it's more interesting to share slides with bullet points, because sharing only slides with images is not very relevant. So feel free to go here to get what I call the annotated slides. About me, so my name is Lætitia Avrot. Sorry, I'm French. It's very difficult to say for non-French people. That's life. I'm pretty sure my parents did that on purpose, but whatever. I'm the PostgreSQL Europe treasurer. I'm also the founder of Postgres Women, and I'm working as a practice leader for Postgres and security at EDB. It's a US company, so I have a very, very nice title, but it does not mean anything to people, so I have to explain. What I'm doing is I'm explaining, or I'm the entry point for any question related to Postgres or its security at EDB for customer-facing people, technical customer-facing people. So customer success managers, technical account managers, consultants, remote DBAs support, and so on. Also, I have a little blog, mydbandnotebook.org, where I try to write things that I want to remember, because, you know, I'm not that young, and sometimes my memory fails me. And also, I launched a thing. I found out that there is no way I can learn if people don't ask their question to me. That's actually my job now. But if you have any question, you can contact me. And then if I might write a blog with the answer, or actually not the truth answer, my answer, because we know that if it was simple, you wouldn't ask the question. So that's another way for me to add blogs to add posts to my blog. And I'm also responsible for this little website. It's not over yet. I have over 100 tips. The final goal is between 200 and 300. So it's only halfway in the best prediction. But what I'm trying to do is to cut PSQL documentation into small tips that you can look when you have some time to spend, you know, when you're in the waiting room for the doctor or things like that. You can just look at some tips to help you with PSQL, because in my opinion, that's the best client ever for Postgres. Forget your GUIs and use the CLI, because that's a really great tool. So let's talk about what we will be talking today. So there are several categories of things that are pain points in Postgres, and I put them into categories I called things that. So you have things that are obvious. Then we will go into things that you don't understand, meaning that Postgres is not Avrot. Then we have things that just happen, and things that are complex. And we will finish with things that should be easier. So, about things that are obvious. So, how many people struggled with the name of Postgres? So, this mug was given to me in PGD Chicago. And actually, there was a display of several mugs. I picked this one, which was the only one misspelled because it's a collector one. And also it proved that it was hand-painted. But it means that people outside the community are struggling with the name. And if you know a little about marketing, names and how you name things do matter. So it's hard to write. Here is examples of what I've seen in my career. So this is the French Postgres, of course. Then I had also Progrès, which is French for progress. I assumed there was some autocorrect here, but who knows? I had the English version, Progress. Of course, the Postgres, whatever. I had Postgres QL. I had Postgras, which is an insult because in French it means post-fat. I had Postgres SQL, and I had Postgres SQL. So, when you name a project, be very careful. And then it's impossible to say. It's that impossible that we do have in the wiki how you have to pronounce it. We even created an audio file, so you don't mess up. But guess what? Each time I'm inviting for an interview, podcast, whatever, people ask me, how should I pronounce it? So we have this say, and I don't know if it's targeted for French people, because we do have a lot of mute letters in French, but it's written Postgres QL, but the Q and the L are mute letters. So it's Postgres. But the problem with that is that we have three names, actually. PostgreSQL, Postgres, and PG for short. We could say that's not a big deal. Everyone knows what we're referring to. The problem is that there are some implications in that. When you're searching the internet, which name will give you the best answers? You don't know. And also, DB engine ranking is based on, well, it's based on several things, but one of them is the internet search for PostgreSQL database and then a question. No one ever did a Google search using PostgreSQL database and what they are looking for. They're using PG, Postgres, or PSQL and what they're looking for. But no one ever will use PostgreSQL database. So that the DB engine ranking for Postgres is wrong, and it's too low compared to what it should be. So that's directly related to the byte choice of the name. Then we have something called an elephant. So the elephant is great. It relates to memory, and when we talk about relational database, we don't want to lose the data, so that's fine. The problem is, it might be a little outdated. So I will go with you into a small dialogue a fictional mother had with her fictional daughter. I will deny having that conversation with my daughter. So the question is, what do you think of the Postgres logo? And the fictional daughter answered, the color is a little insipid, but it's fine. So I insisted, don't you think it feels a little old and outdated? And then she burnt me. Well, it's not a community of youngsters either. Ouch. Yeah, but let's be honest. The logo is outdated, and maybe we could find a way to make it a little better. Because logos is not a thing that you do once and never work on it ever. That's not how it works. So that was the obvious things that are wrong with Postgres. Let's talk about the things that you don't understand. Normally, Postgres is very good with error messages and will give you an explanation of what's going on, and normally it's accurate. But remember, it's still a stupid algorithm. It's not a human. And stupid algorithms tend to be extremely frustrating to humans when you don't understand them, because there is no other way of asking the question, so it will keep repeating the same things. So you know what we all do? We try again without any change, and we still get the same error message. And we're that stupid that we are surprised about it. So here is an example of stupid error message. So this is a pgdump command with several flags. And we get this error, no matching extensions were found. So what does that mean? Is it talking about extension in my Postgres database? What is it talking about? Actually, the problem is that here it's not the right flag, because if you want to use a word as a flag, you need 2 dashes, not 1. So extension related to flags. Maybe not the best choice of word here. Let's see another one that I found on Stack Overflow. So the person is exporting the password, then trying to connect to launch a simple query. So first, let's address that this is totally useful. It's using twice the same flag. But that's the kind of things you will find on Stack Overflow, and people will keep copy-paste that. So because I don't understand anything, but it works there, so I will copy-paste here. And yes, it does not harm anything to have twice the same flag. But it's still not very, very smart. And it says no password supplied. Come on, it's here. I gave it to you. But here you see that you're using sudo, meaning you will clear all the environment variable you had so that the password is not passed. So yeah, again, no password supplies is the right error message, but for a human, it's difficult to understand it, and it's frustrating. That's the kind of thing, when you see that, go out for a walk, and then you will find it. But if you stay in front of your computer, you can spend 4 hours before finding out where's the problem. Let's try something else. This is a function. So regular functions that will return a table of integers. So first, we create a cursor. We create a variable to store text, which will be the query. And then we have an array of text with countries where a majority of people drink tea. England, Turkey, India, Japan, and China. So first, we just initialize the statement. That seems great. Then we will loop over the table. And if it's different from China, then we will add it to the statement with a union. I don't know what happened to China. I don't want to know. Then we will open the cursor with the statement, and we will return the result. So a very simple function. And when we try to launch this function, we will get a syntax error at or near countries with T. That's not very precise, because we use several times this variable in this function. So let's look at it. So we have a reference to that variable line 8, where we define the array, and then we have it here at line 19. Do you know where the error is? Is it on line 8 or on line 18? 8? Raise your hand. No one? 18? Yeah? Okay. Yes, that's on line 18. But the problem is not with countries with T. Well, kind of. The problem is it's an array. You can't do a for loop on an array. You need a for each loop. So, yeah, the problem was here, it's an array, but come on, Postgres. You can be smarter than that. You can tell that you have an array, you can have a for loop. You know that, so why don't you say it? This is another problem I encountered while doing advent of code in SQL. So when you do advent of code of SQL, you have to be ready to write huge scripts of SQL, in particular if you're not very skilled with SQL like me, so that I have a 145 lines of SQL, script of SQL. So when I run it, and it says me there's a problem at line 142 or 43, I'm like, okay, come on, which one? 142 or 43? So, and then it's nice enough to give me the line. So I go, okay, let's go to line 43. It has nothing to do with the line that is underlined in the error message. So let's look at line 142. And nope, not there either. So,
it's line 185, probably.
No. So I looked at the line that was in the error message, and I found out that, of course, I do copy-paste my code. So I have an occurrence at line 94, and another one at line 119. How come Postgres can't give me the right line? Well, it can give me the right line, but not the right line number. Well, let's say it's kind of my fault because I do comment my code. Oh, you can see it here. There are some comments in my code because I'm also very chatty on my code. So the problem is when you are at that part of Postgres, comments have already been stripped off your code so that the line numbers don't match the line number of your script, and that's a problem. Okay, let's go into things that just happen. And I'm not saying there's nothing we can do about it, I'm just saying that actually that should be a trade-off that you agreed on when you used Postgres. For example, logs. Logs are needed to ensure atomicity. We want to be able to roll back any modification query. And also for isolation purpose. We don't want you to read another transaction's uncommitted data. So that's part of the ACID properties. That's normally something you signed when you read the little lines of using an RDBMS. But people are still upset with logs. And I'm like, yeah, and I'm upset with rains, but it still happened. So what can you do to avoid log? Well, you can go to NoSQL. You can lower down your isolation level. That will lower down the probability of having logs, but the default of isolation level for Postgres is read committed, which is already the lowest level. You can go to DB2 that allows you to read uncommitted data. Or if you still want to keep Postgres because you know that it's very serious about your data, you can make shorter transactions, and you can only use DML. DML is data modification language, inserts, updates, select for update, for example, when you want to write. Because I've seen developers using constantly select for update, even when they just wanted to read. So, of course, they will end up with logs. But it can be even worse. You can have deadlocks. So a deadlock occurs when you have one transaction waiting for another transaction to complete, to be able to complete because there's a lock. But this other transaction is waiting for the first one. So this one is very basic, simple, only 2 transactions involved. There can be any number of transactions involved as long as when you do the graph of who logs who, you end up in a cycle. So the only solution Postgres has to solve this is to kill one of the query and just look if there's still a deadlock. If there is still a deadlock, it will kill another query, and so on, until there's no deadlock. That's brutal, but there's no other way of solving it. So remember that the more you will have logs, the higher the probability you will enter a deadlock situation will be. So again, make shorter transactions so you will have less logs, and the probability you will enter a deadlock situation is lower. Use only DML when you want to write, again. Also, there's a little trick that when you update data, or when you write data, try to write them always in the same order, so that the probability that you crisscross transactions is lower. And then, again, if you're very upset with deadlocks, you can go to NoSQL, you can lower down your isolation level, try DB to read and commit it, and so on, because you will have fewer logs. So, again, but it comes with a drawback. Then we have replication lag. So what do we call replication lag? Let's say you have 2 hosts, one primary, one replica. The first one is sending the walls, and then the replica has to write the walls. So the walls is for write-ahead logs. That's where all transactions are written. First, to ensure durability on the primary. In case of crash, we won't lose anything. But also to make sure that we can also use that for streaming replication. So what's the point? What do we call lag? A lag is when the replica is working hard but still getting late from the primary. So normally we express the lag, the replication lag, either in number of walls or in minutes. So what can you do? First, there's something called the laws of physics, and information does not flow without any delay. Of course, normally it's fast, but it can't be faster than your network connection. Also, when you apply on the replica host here, so here on the primary, normally you have several threads modifying your data, because that's a live database. You rarely have only one connection modifying your data. So you have several connections modifying your data here, but then here you have only one process applying your data. So, of course, that can be that can cause a delay. And then I might ask, why is there a delay? Is that a regular delay, or is that something that you observe during peaks? Why is that a problem? Do you want to read from your replica? And so it's a problem because you have a consistency issue. You can perfectly say, OK, I will read from there, but as I want some kind of consistency, it's not perfect consistency, I will use synchronous replication. It means that lag instead of being between the primary and the replica, it will be between the application and the primary, because we will have to wait for the primary to say, okay, the replica has applied my changes, so it's safe, and I can send the acknowledgement to the application. So you will change the lag. Instead of being between both databases host, it will be between the database and the application. And there's no way to remove it. Again, laws of physics. And also, we have a nice theorem called the Park-Elk theorem. It's an evolution of the CAP theorem that you might know. It states that in case of network partitioning, you have to choose between favoring availability or consistency. But else, even though there's no network partitioning, you will still have to choose between latency and consistency. So go search the Park-Elk theorem if you don't know it, but still, you will have some latency somewhere. So maybe your architecture is not right and you want to go to synchronous replication. Maybe your problem is not that you need to go to synchronous replication. Maybe the reads you're doing on your replica is more a no-lap kind of workload where you have OLTP on the primary. In that case, maybe physical streaming replication is not the right choice for you, and you should have chosen something like logical replication, and so on. So first, do think about your architecture and why it's a problem of replication lag. If it's constant, then you do have a problem, I agree, but maybe you should buy more CPUs, more RAM. I don't know if you've seen, but AMD will release new CPUs in December. And they have amazing capability, over 300 threads per CPU. So, and you can have servers with 10 terabytes of RAM. So maybe the problem is that you're running on cheap hardware and you need something more. Maybe, I don't know. It really depends on what you're doing. So, okay, let's go to things that are complex. And I put that picture because we all know that when it's complex, we just wish that it works. Well, not always. So, okay, let's go into something bad. Okay, so I said that Postgres is good with isolation and atomicity so that it can roll back data. To do that, we decided, well, the project decided back in the 90s to do in-place changes. And to do that, instead of deleting physically a row or updating physically a row, what we do is a soft delete and a soft update, well, a soft deletion and insertion when we update, so that we say that this row was created by that transaction number, and all transactions that came before can't see it. Only transactions that came after can see them, and so on. I'm simplifying because I could talk for hours about excited wraparound. But what you need to know is we're in IT, and in IT there's nothing like an infinite number. So that we decided in the 90s that over 2 billion of transactions should be good enough, so we put an integer in it. But nowadays, an integer is not that good, and we can find ourselves in situations where we will wrap around the circle of numbers, and we will corrupt the whole cluster, which is bad and dangerous. Just remember that at the time, in the 90s, Oracle had chosen something different, and this something different is called the undo table space, where they store the previous versions of rows. And who's been hit by the snapshot to old error? Yeah, we know that. So it was not a perfect solution either. So just so you know, there was a project led by ADB at the time. It was called Z-Heap. Why Z-Heap? Because everything is cooler and classier with a Z. Yeah, that's what they told me. But the main point was to change how we... well, it's a huge project, but it was abandoned by ADB because it was it's very complex and difficult. I know Cybertech took it and did some commits in Postgres to help the heap move forward, but we are not there yet. So just remember that that's something that can happen. So to prevent any XID wraparound, what we do is from time to time, we go through the XID, the transactions numbers, and we freeze them. A frozen XID is a special number that is lower to any other. So that from that point, we can keep going and we won't have an XID wraparound. And also, the other problem, if you keep adding data to your database with soft deletion and soft update, then at one point you will be out of space, even though no one can read these old transactions, those dead rows. No one can read them, but it's there. So we're creating something called vacuum. Yay! So it will, well, it's called remove dead rows. It won't give back any storage space. It will only mark as dead some spaces so that it can be reused. So that's what vacuum does. And again, you will see how the Postgres project is good with naming things. So there is an operation called vacuum analyze. It vacuums and analyzes. Analyzing is just gathering statistics, okay? So vacuum analyze means vacuum plus analyze. Great. Vacuum freeze will vacuum and freeze, so create this frozen XID for the ancient rows that needs to keep being there, but are ancient. And then we have vacuum full. It doesn't vacuum plus full. It wouldn't say anything. Actually, vacuum full is a totally different process than vacuum. It will rewrite your whole tables, which might not be what you want. Vacuum full is more like that, if you're old enough to understand. So yeah, that's kind of a defrag of your tables. Why people do hate vacuum? Because it takes resources, and that's true. But remember that vacuum is necessary. Postgres being as nice as it is, should you want to shoot yourself in the foot, Postgres will make sure the bullet enters your foot in the perfect angle to make sure it makes the more damages. So you can deactivate auto vacuum if you want, but it comes with a price. So we have a saying in the Postgres community. It's that if vacuum hurts, well, when we say vacuum, most of the time nowadays we talk about the auto vacuum daemon. So if auto vacuum hurts, it's like sport. It's when, you know, the first time you do sports after having for 10 years being a potato coach, you might be sore the next day. Does it mean you have to stop and quit sports? It might mean that you're not doing it frequently enough. Same thing with auto vacuum. If it hurts, you're not doing it frequently enough. And why that? Because the stupid default values of auto vacuum. And why that? Because we decided that Postgres should run even on a Raspberry Pi first generation. We have no idea on what you will be running it. But what we know is we don't want it to fail, because stability is really important to the Postgres project, so that we will make it run but we will prevent it to run smoothly. So whatever you do, if you install a fresh cluster, don't use a configuration out of the box and tune it. And also, it's very difficult to find the best values because, well, best values has to be related to at the time. So it will change over time. That's the first thing. And second, we don't know your workload. We don't know what you will be doing with Postgres. Postgres is generalist. It can do a lot of things. So you have to figure it out. We have good starting notes in the community that we know, that we share, but you will have to figure it out for your own cluster. And then we have collation, so I'm not talking about small snacks. I'm talking about how we will sort text data. So collations depend on glibc in Postgres. And that's a problem, because your glibc is embedded inside your operating system. And should you change your major version operating system or decide to go from whatever, Red Hat to Ubuntu or whatever you want, you might corrupt your indexes or your data, which is not nice. So we try to make it better. Now we have, in Postgres 17, we have an internal collation. We also have information about the collation that is used for your data, so that at least you might know that there might be a problem with your grade, your subgrade of whatever. And yeah, Jeremy will talk about that this afternoon, because he will be talking about production nightmares, and that's one of them. Okay, there are things that should be easier in Postgres. Have you ever run 50+ lines queries just to do simple administrative tasks in Postgres? No more than that? Okay. Well, this is a script taken from a PGX script. I really encourage you to go there if you don't know that GitHub repo. It's a goldmine. So this script is meant to give information about index bloat. Do you know how many lines in this script? Who think it's a 10-line script? Yeah, no, it's already more than 10. 20? Who thinks it's 20? 50? Over 100? Over 200? Over 300? No, it's 101. Oh. But come on, it should be easier to get bloat information, because that's a major problem of Postgres. We do know it, so we should have a convenient way to provide this information. Okay, this one, I love it. So it's another bloat query to gather the bloat information from tables, but look at this comment. Is often off by plus or minus 20%. So it's an estimate. By the way, the previous one was also an estimate. How many lines in that script? Okay, let's over 100? Over 200? 300? No, it's 140, but already impressive just to gather bloat information. So if you want a patch ID, I want a system administration function to gather bloat estimates. It does not have to be accurate to exactly the value. An estimate is fine enough, but it is fine, but it has to be close enough. Here is another script. If you want to see all the permissions a user have, including the one he has by being granting another role and so on, then how many lines of SQL will you have to run to do that? More than 50? 177, just to gather that information. Yeah. So again, that's the kind of thing that could be easier. And again, I'd like to see an administration function to have this information, and we could also add it to the meta command of PSQL \du. And then we've all been there when you have to do major upgrade. So major upgrades by themselves are not that tricky. The problem is when you're using extensions and when you have a very, very tiny maintenance window, then you have a problem. But you know that Postgres rely on an internal catalog called the PG, that you can query actually in the schema PG catalog. And between major versions, this catalog can change. And there's no other way than using PG upgrade to or logical export and reimport to have your data be compliant with the next major version. So that's a flexibility the project wants to keep, but the project is nice enough to support 5 major versions. I haven't seen any other project supporting that many major versions. So please do it. You have each time 5 years to upgrade. I wouldn't recommend to upgrade to Postgres 12 now. Obviously, I would recommend to go to 17. But do what you can also with the resources you have. But don't run on an old version. And the next one I want to be improved is partitioning. There is no automatic creation of the new partitions, especially for time series. That's something we could create. People will tell me there is a PG Partman extension, but why can't Postgres do it? It seems like only half of the job has been done. So we could get better on that. So it's time to conclude. Just to make it right, Postgres is good. I'm not saying you shouldn't use Postgres. Postgres is really good. Sometimes I've seen the problem is the user of Postgres, which is fine because sometimes, well, who does read all the small lines in the contract before signing it? No one. So it's OK. But there also are some real pain points that we would like to solve in Postgres. So if you're feeling like you can help, you're welcome to come and help. If you're feeling that you can't help, that's not true. You can. And so I will take a few questions if there are.
Thank you very much, Lætitia. So we have time for one question. If we have, I want that to be a question, not a comment, because for comments we have the break, and in the break you can talk with Lætitia and with everybody about this kind of stuff. So we have one question here.
Is there any of these examples that you have been personally burned with?
The logo one? Actually, I'm a consultant. I was a consultant for a lot of time. I have no production. I've seen it at my customers, but it's not my babies. That still hurts.
Okay, good. So again, a round of applause for Lætitia. Thank you very much.